Hello, this is Michael. In this video, we're going to look at a proof of the Pythagorean Theorem. It says a squared plus b squared equals c squared. This proof is attributed to President Garfield. He was a math teacher early in his work life, way before he became president. Now, to understand this, you'll need to know some basic algebra, and you'll need to know some formulas for area. The area of a triangle, half times base times height. And the area of a trapezoid, 1/2 times b1 plus b2 times h. So if you don't know these things, you need to learn some geometry, go learn about the area of a triangle and the area of a trapezoid, because without that knowledge, you can't really get this chain of reasoning. You might want to just brush up on it, but of course you can still watch through the video. We also need to know some basic geometry. The angles of a triangle add to 180 degrees, and the angles around a point and on one side of a line add to 180 degrees. But first, why do this? Who cares? Because you need to train yourself to go by reason and the evidence of the senses, not just follow some supposed authority. You should not just memorize formulas without knowing where they come from or why. Learning this proof is one small step in preserving your mind's integrity. No one will do this for you. You need to take care of it yourself and do this yourself. You should know from where your ideas are derived. Too often in education today, we are told stuff without any justification or explanation. No reasoning, no logic. We are trained to do what we are told. Our independent thought is ignored or stifled. We are not trained to see things with our own minds. We're not trained to induce and figure things out on our own. Induction is deriving generalizations from particulars. Usually, people just think, yeah, okay, tell me what I need to know for the test. You learn it, you forget it. That's not a good idea. That's unhealthy. We need ideas connected to reality. We need to have and to demand good reasons to believe claims. We need the habits of mind to know when a politician is being misleading or irrational, and the habits of mind to know which ones are being reasonable. Unfortunately, they have a major influence on our lives today, so it's a serious issue. We need the habits of mind to know if a health claim is valid or not. Is fat good for you or bad for you? Should you run long distances? Do lots of cardio to be healthy? How do you even research that? So you need to train yourself to go by the evidence of the senses and to reason things out, not to go by some supposed authority. You should not merely memorize what you're told. Learning this proof is one small step in preserving your mind's integrity. And the theorem helps with detailed practical matters like cutting a board or piece of metal to support a gate. You see that in the picture here. The slanted bar is the hypotenuse of a right triangle. If we go up one side along the brick and then over the horizontal bar from left to right, and then go back down on the diagonal is the hypotenuse. In this case, it's metal. You could have a gate made of wood where the bar is wood. The theorem also could be used for building a wall perpendicular to the ground or perpendicular to another wall. If you know a squared plus b squared equals c squared, such as 3 squared plus 4 squared equals 5 squared, if you make a triangle of those dimensions in feet or inches, you know for sure it's a right triangle. And so if it fits properly, you know your wall is perpendicular to the ground, or you know two walls are perpendicular to each other. It's also important in finding the distance between points in a grid system. That's very important for locating objects. It's important for finding the largest distance in a crystal like salt. It's important for finding the diagonal distance across a table from like top to bottom, opposite sides. It's important for calculating the length of a guy wire. And it's important in the composition of forces in engineering and physics. and lots more. Here are guy wires, by the way. You see they're the wires supporting this tower. Could be something holding up a smaller pole also. And here's some similar basic things on a boat. So you see if we go from the wire to the mast and then across the surface of the boat, we make a right triangle, if you can picture that. If not, it's all right. You'll get used to it. So let's do the proof. Now you might want to write things down and keep track as we go. Sometime you might want to watch the whole video, maybe watch it again and stop it at places, be writing things down on paper so you see what's going on. You make sure you understand it yourself. So Garfield, he started with the right triangle. We all know what that is. It's a triangle with one right angle. We'll name the sides A, B, and C. He drew another right triangle of the same dimensions and touching the first. So you can see they're both of dimensions A, B, and C, and they're both right triangles. Then he joined two endpoints of the triangles to get a trapezoid. He used area and algebra to prove the theorem, remember? Now we can look at the area in two ways. There's the area of the whole trapezoid, which you can see in blue. The top and bottom are parallel to each other. Or we can look at this as the area of three triangles. So we got the blue, the green, and the black. To recap, and so you see the trapezoid in the triangles in the diagram, even though it's not colored. So we got the area of the whole trapezoid, or we can add up the three triangles and we get the same area. So looking at the trapezoid. The area of a trapezoid is 1/2 times B1 plus B2 times H. H is the height. We got that written in red there, and you see it's equal to A plus B. Base 1 is in blue, and you see that's equal to A up there on top. Base 2 in orange, it's at the bottom, and that's equal to B. So you can match up the equations with the diagram, and it's color-coded. Now we substitute those things into the formula, and it's color-coded so you can match things up. So we've got 1/2 times A plus B times A plus B. And you can pause that a second if you need to, make sure you're understanding what's going on. Now you might want to write that down. If you're not writing things down, we're going to use that in a minute. So now let's look at this as triangles. Now the three triangles are right triangles. Two we already know, but the third one in green we need to prove is a right triangle. Again, you need to learn, don't just take someone's word for it. You need to trace things down to basics, down to fundamentals when you can, reason things out from what you know, make sure it's right. So, if you look at the bottom triangle, we know angle 1 plus angle 2 plus 90 is 180 degrees. That's in the bottom triangle there. You see that in blue. But we know 90 and 90 is 180. So when you match that up, you see that the angle 1 plus the angle 2 must equal 90 degrees. Now, if we look at angle 1, 2, and 3, they are angles around a point on one side of a straight line. We know they add up to 180 degrees. So angle 1 plus angle 2 plus angle 3 is 180 degrees. But angle 1 plus angle 2 is 90 degrees. And again, we know 90 plus 90 is the 180. Well, if 1 and 2 are 90, then that means that angle 3 must equal 90 degrees. So that triangle there, where angle 3 is, that's a right angle, so it's a right triangle. So all three triangles are right triangles. We have proven that. Now the area of a triangle is 1/2 times base times height. So in this case, we have the triangle on top, the blue one is 1/2 AB. The triangle on bottom, the green one, is also 1/2 AB, base times height again. Because base and height are perpendicular to each other in a triangle. And then the third one in black, 1/2 C squared. So the area totals to 1/2 AB plus 1/2 AB plus 1/2 C squared. And that equals AB plus 1/2 C squared, because half AB plus half AB is AB. You know, half of something plus half of the same thing is the whole thing. Half of a pie plus the other half of a pie is the whole pie. So to recap, the area of the figure looked at as a trapezoid is 1/2 times A plus B times A plus B. But looked at as the sum of three triangles, it's AB plus 1/2 C squared. So they're equal to each other. 1/2 A plus B times A plus B is AB plus 1/2 C squared. Now we're going to do a little algebra. So we have the formula we had written down earlier. Now if we multiply both sides of the equation by 2, on the left we'd have half times 2, which is 1. You know, like half a dollar and half a dollar makes $1. So we're left with A plus B times A plus B. On the right, 2 times AB is 2AB. And again, with the half C squared, if you have half times 2, you get 1. So we got 1C squared. Now the A plus B times A plus B, we FOIL that out. And that'll be A squared plus AB plus AB plus B squared. Now notice on the left and on the right, we have two ABs, because AB plus AB is 2AB. So they cancel each other out. If we subtract that away, on the left, we're left with A squared plus B squared, and on the right, we have C squared. And so we're done. QED. So now we know, we have reasoned out that A squared plus B squared is C squared. We know it for a fact. So good job. Thanks for watching. Now, my recommendation is that you memorize this proof and learn others. Memorizing proofs will help you train your memory to connect long trains of reasoning and to give information you want when you ask for it. And memorizing the proof will help you be a better reasoner, since you will be habituating the reasoning process. Thank you for watching, and I hope you have a good day.